Alright team, let's use an MVP chart to calculate the initial velocity, the final velocity, or mass of an object in an inelastic collision or explosion. Okay, so this is pretty much a math problem, but luckily for us, we got a really nice graphic organizer to help us along the way, but there are some things that you got to know, that you definitely need to know. So, mass times velocity equals momentum. So this is an absolute must know, equals momentum, and I believe at this point most of y'all know this. If you don't have this memorized, then make a flashcard and memorize that. The total momentum, and then this is something else that we need to know, the total momentum before a collision will equal the total momentum after a collision. This is the law of conservation of momentum. And this law allows us to make the predictions that we do, or this law really allows us to solve these problems. You're going to need to know how to draw an MVP chart. And no, I'm not going to give you this on tests and quizzes. You're going to need to know how to draw it. And so let's just kind of remember, you have a collision and you're going to divide the collision up between the time before the collision and the time after the collision. So the initial conditions and the final conditions. And before the collision, you'll have each object with a mass, velocity, and a momentum. You can calculate the total momentum, and you're going to have two objects. We're not going to do more than two, thank goodness. So we're going to have red and blue carts in this case, in most cases, but it could really be anything. Like it could be a dog colliding with a cat, or a baseball bat colliding with a baseball. It doesn't matter. But for the purpose of just like learning how to do this, let's just do red and blue carts because we've kind of seen these before. Now, the conditions after the collision. Just noticing how this MVP chart is set up, it says red and blue. This tells me that the objects stuck together after the collision, so it tells me that it's an inelastic collision. So this part of the table tells me that it's an inelastic collision because they're stuck together. But anyways, I think the best way to do this is just to solve a couple problems and understand the concepts behind solving or using the MVP chart. So let's read this one. A 2-kilogram red car moving to the right at 2 meters per second collides inelastically with a 4-kilogram blue car moving at 3 meters per second to the left. What is the velocity of the two cars after they collide? The first thing I'm going to do is just write P equals mv. I'm going to write it over here. P equals mass times velocity, just so I don't forget it. And I'm going to analyze this for some special things. So it's moving to the right at 2 meters. The red car is moving to the right at 2 meters per second. So I know that this is going to be a positive velocity, and the red car is going to have a positive momentum. And it collides inelastically. So I know that the two cars are going to stick together. They're going to stick. It says the blue car is moving at 3 meters per second to the left, which means that this velocity is a negative velocity. Okay? So what is the velocity of the two cars after they collide? So I don't know the final velocity of both of the cars. So that's what I'm trying to find out. So lots of ways to analyze. So that's my first step. I'm kind of breaking apart. I'm trying to draw a question mark here. Boom, boom, boom. I'm just analyzing the prompt or the question for clues. So the carts start separate and they end stuck together. So I can draw an MVP chart just like this, where the carts start separate and they end together. So let's just practice drawing these MVP charts. So we have conditions before, we have conditions after. I'm just going to draw a line down the center. Boom. And MVP, MVP, P. It really just is as easy as that. If you want to remember P total, that's fine too. But that's going to set us up. So what I want to do, oh yeah, one more thing that you can analyze too is just quickly in your head, get a picture for what's going on. If the red car has 2 kilograms and it's moving at 2 meters per second, then I already know that it has a momentum of 4 kilograms meters per second. So it has 4 kilograms meters per second. The blue car has 4 times 3, so it has 12. So the blue car has more momentum. So when they collide and stick together, they're going to be moving to the left. They're going to be moving in whatever direction the blue car was moving at. So that's just a good way to think about it. So hopefully, when we finish, we have that'll be a true thing. And you know, a really key thing is to have everything nice and organized. And just looking at how I have this now, because I analyzed this with kind of bad handwriting, it's gonna look a little slipshod. And so I think for you guys, it's going to be really important to be better than I am with your handwriting and keeping things organized. Part of it is I'm really bad with this stylus pen. Oh, why don't I have an Apple pen? Okay, so now our next step is to fill in everything that we know. We know that the mass of the red car is 2 kilograms. We know that its velocity is positive 2. And we know that the momentum is 4 because P equals mv, mass times velocity equals momentum. The blue car has a mass of 4 kilograms. We've already made sure that we're never going to forget this ever, that it's moving to the left, so we have a negative velocity, and we know that its momentum is 4 times negative 3, which is negative 12. So what is its total momentum? What is the total momentum of both objects together before the collision? Well, 4 plus a negative 12, so 4 plus a negative 12 is a negative 8. Negative 8. I just add these two numbers together. 4 plus negative 12 equals negative 8. Cool. Now, at this stage, we can remember the law of conservation of momentum. We know that the total momentum before the collision equals the total momentum after the collision. So I can fill this in. I am allowed to because of the law of conservation of momentum. Okay? That allows me to make this next step, this next prediction. So both of these cars together, if we think about their mass, one car is 2 kilograms, the other car is 4 kilograms. So together they have a mass of 6 kilograms. Together they have a mass of 6 kilograms. And we know that the momentum of both of them together is negative 8 because we know that they stuck together. And we know that because it said that they collided inelastically. Now our last thing is solving velocity. Now, a lot of people, they go, oh, cool, the velocity is 2 minus 3, so the velocity must be negative 1. Well, that's not true. You cannot add velocities. And I'm pausing there because I want you to really absorb it. You cannot add velocities like that. Not allowed. You can add masses, cannot add velocities. So how do we solve this? We'll use our homie algebroni. Green, why not? Okay, so mass times velocity equals momentum. Plug in everything you know. You know that the mass is 6, and the velocity you don't know, and the momentum is negative 8. Okay? So you can use your calculator or just use your algebra skills. Divide this side by 6. That way these cancel out. Whatever you do to one side, you do to the other. Negative 8 divided by 6 is V equals negative 1.39. repeating. That little line is called, it just means that it's 1.33333. 1.3 repeating meters per second. And we are allowed to make this prediction because of the law of conservation of momentum. And we know that the objects are moving to the left, which is what we predicted initially, given that the blue car had more momentum. Okay, so that's how we use an MVP chart. So let's just add that negative 1.3 repeating. And you know, in physics, I always say never forget your units. In this case, I avoid the units because it just has a lot more things that I need to write. Let's look at another example. A 4-kilogram red cart moves to the right at 5 meters per second, and it collides inelastically with a blue cart of unknown mass at rest. After the collision, the objects are moving together at 2 meters per second. What is the mass of the blue cart? So right off the bat, let's write down some things we know. We don't know the mass of the blue cart, so the mass of blue is a mystery. We know that the red car is moving to the right, so we know that this velocity is a positive velocity. The objects are moving together at 2 meters per second, and it is a positive velocity. So we have a positive velocity there. We see that they collide inelastically, so we know that they stick. And this is the kicker. Unknown mass at rest. If you don't notice this, it's going to be impossible. What does at rest mean? It means that you're moving at 0 meters per second. So we don't know the mass of the blue car, but we do know the velocity. We know that it's moving at 0 meters per second. And luckily for us, mass, anything times 0 is 0. Anything times 0 is 0, so we're going to remember that. Okay, step 1, we got to draw our MVP chart. It's an inelastic collision, so we can do the same thing that we always do. Before, after, I draw a line. MVP, MVP, and then our total, B total. Okay, so let's start filling in what we know. We know that the mass of the red cart is 4. It's moving to the right at positive 5 meters per second. It's got a momentum of 20. We know that the blue car has an unknown mass. We don't know it, but we do know it's at rest, so it's moving at 0 meters per second. I want this to trigger a mental note for you guys. If you know that mass times velocity equals momentum, and you have anything times 0, you know that your result will also be 0. So this blue cart doesn't have any momentum to start with. So we are allowed to add up the momentum of the two objects, which is 20, positive 20, and we know because of the law of conservation of momentum that the momentum after the collision is also 20. So we know some other things. We know that the velocity of the objects after the collision is 2 meters per second, so let's fill that in, 2. And we know that the P is 20 because they stuck together, so we know that their final momentum together is 20 kilograms meters per second. And finding the mass is as simple as using your homie Algebroni. I'll use green again, I don't know why. So mass times velocity equals momentum. We know that the mass is unknown, the velocity is 2, and the momentum is 20. So I got to divide both sides by 2 to get rid of that. Whatever you do to one side, you do to the other. M equals 10. And some people will be jumping for joy. They're like, cool, the mass of the blue card is 10. I got the right answer. I win. But you would be wrong, because it's not the mass of the blue car that you just solved for. You just solved for the mass of the system after the collision. You know the mass of the blue car. So if the mass of both of them together is 10, and the mass of the red car is 4, then the blue car's mass is whatever's left over. So the mass of the blue car is 6. So the mass of the blue car is 6. So what's the answer to this question? What is the mass of the blue car? The mass of the blue car is 10 minus 4 equals 6 kilograms. And that is your answer, okay? So don't forget a couple things in this. Multiplying by 0 equals 0. And don't forget that your total mass, you need to do one step further and find the mass of the blue car by subtracting the mass of the red car. Last example, a 2 kilogram red car is moving at an unknown velocity. It collides with the 4 kilogram blue car moving at 6 meters per second to the left. Let's go super fast here. This is going to be a negative velocity. We don't know the velocity of the red car. We don't know the velocity of the red car. We know its mass. After the collision, the carts are moving together. This is a hint that it's an inelastic collision, and they're moving to the left at 5 meters per second. So this is going to be a negative velocity after the collision. So let's just jump right into our MVP chart. I want you guys to be able to draw an MVP chart just from memory. So we have before the collision, MVP, after the collision, MVP. And let's fill in what we know. We know that the red cart is 2 kilograms. We don't know its velocity. And we can't just multiply and know. It's not multiplying by a 0 this time, so we actually don't know the momentum of the red car. Now, the blue car, we do know everything that we need to know about this one. We know that the blue car is 4 kilograms, and we know that it's moving to the left, -6. And 4 times -6 is 24. I almost messed up 4 times 6 in my head, but so it goes. We all make mistakes. -24. And the reason I'm using purple is because red and blue together is purple. We know the mass of them together. The mass of the red is 2. The mass of the blue is 4. So together, they have a mass of 6. The velocity, we know it gave it to us in the prompt. Always, if you're like, I don't know what to write, look back at the prompt. They're moving to the left at -5. 6 times -5 is -30. So we know that the total momentum before the collision is -30. Therefore, we know that the momentum, after the collision is -30. Therefore, we know that the total momentum of the system before the collision is -30. How do we know that? In class, how do we know this? How do we know this? We know this because of the law of conservation of momentum. So if together the momentum is -30 and the momentum of the blue car is -24, then you have to solve for what the red car's momentum is. And we know that -6 plus -24 equals -30. So you're gonna solve for that unknown momentum there, because you know that the momentum of the red plus the momentum of the blue equals the total momentum. So you could maybe use that formula if you get stuck and you can't come up with a number just in your head like I just did. Now, solve for V using the same formula, M times V equals P. We just divide both sides by 2. 2 times V equals -6. Divide both sides by 2, and you get V equals -3. Do-do-do-do-do. Feels good. We got it. Now you might be thinking, wait a second here. This doesn't make sense. Is it possible that they both have a negative velocity? Sure, it's possible. Yeah, the blue car's moving a lot faster, so it just caught up with the red car and then collided with it and stuck together, and then, it's slowed down a bit. So that's totally fine. So what is the velocity? Oh my gosh, I forgot to write down the question. I forgot to write down the question, but we filled out the MVP chart, which is basically the gist of where we're trying to get here. So we can say the velocity of the red car equals -3 meters per second. We solved for any unknowns in this case, although in all cases on a test or whatever, it'll be there'll be a specific question that you have to solve for. Okay, just some quick background and then we'll wrap up. Elastic collision. Objects bounce off from one another when they collide. Inelastic collision. Objects stick together. Stick when they collide. An explosion. Objects push off from one another. Treat objects as one big mass when they are stuck together. And analyze the question for negative velocities and the type of collision. So you want to see if it's an inelastic or an elastic collision. You want to be able to draw an MVP chart by hand from memory. Fill in all the values that are known. Remember that objects moving to the left should have a negative velocity and a negative momentum. And you want to calculate the momentum of the object by multiplying velocity times the mass. You find the total momentum by adding the momentum of each object together by adding. And you want to solve for any unknown variable using the same momentum equation, P equals mv, by filling in whatever you don't know and just doing simple 5th grade algebra to figure out whatever your unknown variable is. You want to add the mass. I'm going to say this again because we always forget. Add the mass together when the objects are stuck together, and do not add velocity. You're not allowed to add velocities, people. You'll see. You shall see. So you're never adding velocities in this case. All right, guys. Sorry that video took way longer than I wanted it to, but peace, love, happy physics.